Okay, this is lesson 4.7, which is solving real-world systems, and we're going to use substitution. So example 1, I'm going to read the question first, then define my variables before I go and write my equations. So Nicole spent $44 on gifts for her friends, Tina and Rose. She spent $10 more for Tina than she did for Rose. How much did she spend on each friend? So this last sentence, what it does is it tells us not only what we're solving for, but it helps us define our variables. Because how much did she spend on each friend? Her friends are Tina and Rose. So it's how much money she spent on Tina and how much money she spent on Rose. Those are our variables. T will equal money spent on Tina. R will equal money spent on Rose. So now I'm going to go back, reread, and see if I can write some equations. Nicole spent a total of 44 gifts on her friends. A total of $44. This tells us there's an equation where we sum two things together to equal 44, right? A total of $44 on gifts for her friends, Tina and Rose. So she spent some money on Tina, she spent some money on Rose, and when we add those together, they equal 44. She spent 10 more for Tina than she did for Rose. She spent 10 more for Tina than she did for Rose, making Tina the dependent variable. So T equals. Let's go back. She spent 10 more, so plus 10 at the end, on Tina than she did for Rose. So however much money Rose is, plus 10. Okay. Moving forward, now that we have T isolated, we can go ahead and substitute that into the first equation. So T plus R equals 44. We're going to solve this at T equals R plus 10. So I'll substitute this in for T. Then, since there's a positive 1 here, the parentheses actually just drop. Combine like terms. In order to isolate R, I'm going to subtract 10 on both sides. Lastly, divide by 2. R equals 17. So what does this mean? I'm going to go ahead and interpret it now. This means she spent $17 on Rose. Now we'll go back and we're going to substitute this in to this equation. So anywhere that I see an R, I'm going to substitute 17, which is 27. So T equals 27, meaning she spent $17 on Rose and $27 on Tina. Which makes sense because 17 plus 27 is 44, and she spent 10 more on Tina than she did on Rose. Moving on to example 2, again I'm going to read it first, and then I will go back and I will start to define things. There are 23 students, boys and girls, in a math class. The number of girls is 2 less than 4 times the number of boys. How many girls are in the class? So we're solving for girls. So our variables are G for number of girls, especially since that's what we're solving for. And we have boys in this class too, so B equals number of boys. Let's go back so we can write our equation. There are 23 students, boys and girls, in a math class. So although it doesn't say it, this is referring to a total. There are a total of 23 students in the classroom, so equals 23. Two things summed together will equal 23. That will be the number of boys plus the number of girls. The number of girls is. Girls is. That means G equals 2 less then 4 times the number of boys. Perfect. Here's my system. G is already isolated, so I'm going to substitute that into the first equation. B plus G equals 23 at G equals 4B minus 2. I'm going to substitute 4B minus 2 in for G. There would be a positive 1 in front here, so the parentheses just drop. Combine like terms. I have 1B and 4B, which is 5B. Add 2 to both sides. 5B equals 25. Divide by 5. B equals 5. But we're solving for the number of girls, so I'll substitute at B equals 5. So everywhere that I see a B, I'm going to substitute 5. Which is 20 minus 2, which is 18. So there are 18 girls in the class. Excellent. Last one, and this one's a little bit different. Again, I'll read the whole thing, define my variables, then start solving. Miss Langston wants to spend $120 to stock her refrigerator with orange juice and milk. Her refrigerator can hold exactly 32 containers. A container of orange juice costs $5, and a container of milk costs $3. How many of each will she buy? Sorry, I had a typo. So how many of each will she buy? Each what? How many of each what? We're talking about each container of orange juice and containers of milk. So let's let M equal number of milk containers. And then it'd be OJ, so let's say J equals the number of juice containers. Let's go back and write our equations. Miss Langston wants to spend $120 to stock her refrigerator. So if she wants to spend $120, this is a total. And we're adding 2 things together. Her refrigerator can hold exactly 32 containers. If it can hold exactly 32 containers, this is also a total. Because there's a total of 32 containers that are going in her refrigerator. Now, it says a container of orange juice costs $5. This, just so you know, anytime you have something like that, it'll be $5 times the number of orange juice containers, 5J. And a container of milk costs 3. So this is 3 times M. Since this deals with money, it's going to go in the money equation, $120. So 5J plus 3M. 32 refers to a total number of containers, and look at that. So M plus J equals 32. Now, I can't just substitute. I need to first isolate from the second equation. And I'm going to go ahead and isolate M just because I feel like it. It doesn't matter. Sorry. So I'm going to subtract J from both sides. M equals 32 minus J. And I'm going to substitute that back in to the first equation. 5J plus 3M equals 120 at M equals 32 minus J. So everywhere that I see an M, I'm going to substitute 32 minus J. Use parentheses when you substitute. I'm going to go ahead and I'm going to distribute the negative 3, or the positive 3, sorry, to both. 32 times 3, 96. Combine like terms. Subtract 96 from both sides. So I need to borrow again. Divide both sides by 2. J equals 12. So there are 12 containers of orange juice. Now to solve for milk, I substitute J equals 12 into, say, M plus J. So M plus 12 equals 32. Subtract 12 on both sides. M equals 20. 20 containers of milk. I did these pretty fast, so make sure if you have any questions that you go back and you re-watch and press pause where you're confused.